Good afternoon, students. You are welcome to Scholars Universal School online classes. This is chemistry, and today's topic is carbon and its compound. So we'll be looking at the part 1 of the carbon and its compound. We will always tell you that you are very good, so you can fly high in your studies. Kindly subscribe to our YouTube channel. First, we're going to look at the way carbon is. This picture is showing a typical example of carbon. Of course, one way or the other, we have heard of carbon, probably at home, in our generator, or probably in our kitchen, as probably in form of charcoal, or in form of coal that we use in our coal pots. So somehow, even in form of diamond that is used in jewelry and ornamentals. So somehow we have heard of carbon. Carbon is a non-metal, and it has been known for a long time. Just as I said, you can have it in form of diamond. You can have it in form of coal. We even have it in form of compounds such as petroleum, such as wood, some living things, triazocarbonate 4 salt, hydrogen triazocarbonate 4, then such as limestone, and such as magnesium triazocarbonate 4, which we call dolomite. Petroleum and wood are very important source of fuel for light, heat, and electricity generating plants. And all these contain carbon. So carbon are usually studied under organic chemistry, but we also study few ones. That's the compound of carbon. We also study few ones under inorganic chemistry, such as oxide of carbon. When we say oxide of carbon, carbon 2 oxide, carbon 4 oxide, then we have sulfide. For example, carbon disulfide. We have metallic carbide. We have triazocarbonate 4. We have hydrogen triazocarbonate 4, and then some other minor compounds that are included under inorganic chemistry. Now, let us consider what we call allotropes of carbon. Now, let us look at this. This is a carbon, diamond. This is another carbon, which is graphite. Look at this tip. I'm not talking of here, but this tip is graphite. Look at this fluorine. Look at this soot, like the one that you see at the back of your cooking pot, that you can scrape from your from the back of your cooking pot. So you can see all these are carbon, but you can see them. They are in different forms. Although they have the same physical state, well, if you say they are solid, they are all solid, the same physical state, but they are in different forms. This is dark, this is not dark, this is also dark, but this is darker than this. This is in form of powder, and this is just in form of a crystal. So when a substance exists this way, that is having the same physical state but in different forms, we call that phenomenon allotropy. And the elements involved are called allotropes. For example, now, diamond here, graphite, fluorine, soot. Anyway, fluorine is not what we consider at this level. So if you are asked about the allotrope of carbon at this level, you think of two areas: the crystalline allotrope of carbon, which are diamond and graphite, and the non-crystalline allotrope of carbon, which is soot. So fluorine is not yet that popular at this level. So you can read here, allotrope is the ability of an element to exist in various forms but have different physical states. Allotropes are two or more substances or elements in the same physical state but in different forms. So just as I said, the crystalline allotrope of carbon are diamond and graphite. and the non-crystalline allotrope of carbon. So we have coke, we have coal, we have lamp black, soot, charcoal. And when we talk of charcoal here now, it could be plant charcoal, it could be animal charcoal, it could be sugar charcoal, it could be any form of charcoal. Then, so we call them amorphous because they are non-crystalline form of carbon. So let us take a broad look at these two allotropes. This is diamond and this is graphite. These are the two major allotropes of carbon that we'll be considering at this level. So you can see, you can spot the difference. See how shiny this one is, and see, though this one is also shiny, but it is dark, very dark. So you can hardly think, if you are not told or if science has not revealed, you can hardly think of the fact that this diamond here and graphite are of the same origin, and they both contain the same thing, and that they both contain the same element, and that they are both carbon. So this shows why the differences in the diamond and graphite, in terms of their nature, in terms of their hardness, and in terms of how soft graphite is and how hard diamond is. So this is having octahedral shape, that's the diamond, whereas when you look at graphite, it's having hexagonal. Of course, the hexagonal structure of graphite can be shown here. Each of this is a hexagon, and this is how they are joined in layer, and you now have the layer of this over one another. So we say graphite is hexagonal in shape. Then we have diamond as a octahedra in shape. So let us consider the allotrope of carbon separately now. First, we'll be talking about diamond. You can see this beautiful this beautiful thing here. Yes, this is a good example of diamond. You can see how shiny it is. You can see that it's having refractive index. In fact, if care is not taken, you would think that is a glass, is a form of glass, but it's no, it is not a form of glass, it is diamond. And don't be surprised that this is carbon. Now, we can find diamond in Africa, especially, okay, we can find it in Africa, we can find it in Brazil, India, and so on and so forth, Guyana, Siberia. So, can find diamond there. So diamond is so important to us because it is used for a lot of things. One, it is the purest substance, or the purest form of carbon rather. It is the purest form of carbon. So diamond is colorless and it can be transformed into a very brilliant ornament or gems. In fact, it's a gemstone. At times, you may see some diamond with some colors, characteristic colors. That color, so it is not really that diamond has that color, but it is because of some impurities that are associated or that are associated with diamond. So those impurities actually give it those color. So let us look at the property of diamond. One, just as we have said, it is the purest form of carbon. It is the hardest substance that is ever known on Earth. Then it has high melting point. It is very dense and resistant to high temperature. That means it cannot be destroyed by high temperature or chemical attack. Even acid cannot attack it, unlike when acid gets in contact with iron, for example, the iron will get bad, the iron will be eaten up. So likewise, some other metals like zinc, like copper, so they can easily be they can easily be affected by acid, for example. Even ordinary water, moisture, and air can actually cause rusting for iron. But for diamond, it does not subject itself to such chemical attack. So it is a non-conductor of electricity. This is because diamond does not have a mobile electron in its outermost shell. Diamond does not have a mobile electron in its outermost shell. None of the valence electron is free. So that is why it cannot conduct electricity. You know that flow of current is as a result of flow of electrons in solid. If there's no flow of electron, there cannot be electricity generation, and that is why electricity cannot be generated in diamond. Sorry, that is why diamond cannot effect a flow of electricity. Just as with that, it is the hardest substance, and because of the fact that it is the hardest substance, it is being put to various use that require very hard materials. For example, in production of rock borer for mining. You see, in mining, so usually many of the mineral resources that are to be mined are always found beneath the rocks. Even if you want to drill ordinary borehole in some areas, for example, in Abeokuta, to drill borehole there is not going to be easy because of rocks there. You need some rock borers, and these rock borers should be hard enough to break rocks. The only thing that can be used to produce such a tool is diamond. So when you look at the rock borers here, these are examples of rock borers. So all these tips that you see here are actually made of diamond because of their hardness. It is these tips that will break rocks when drilling. So these are examples of rock borers. We also have it in production of dies, and this die is always used in drawing wires. Then we have it in production of cutting tools, which we always use to cut through a metal. That's to cut through another metal. So it is used in making tools for cutting glasses and metals. It is also used as a building pivot support for building pivot supports in precision instruments. So let us consider this sixth use of diamonds. Are these not beautiful? You can see this ornament here. I know you would like to have it in your home. Then this is the diamond ring. It is an engagement ring. I know if you are a girl or a woman here, you would like to have this as your engagement ring. So you can see how beautiful they are. Then see this necklace. All these are made of diamond. This is a diamond ring. These are diamond rings. They are diamond ornaments, diamond necklace. See how beautiful they are. So because of the high refractive index and because of the high dispersion power, that is, when light actually strike the surface of diamond, it shines back, and you can actually appreciate the beauty of the material of diamond. So that's why it is used in making all this jewelry, because of the high refractive index and high dispersion power. So let us consider with the uses. It is also used as a switch in high power stations. We use it to develop high power switches in power stations. For example, in electricity transmission station, so diamond can be used as part of the switches. Well, probably because of its hardness, and probably because it cannot easily be melted. So let us consider the fifth one. So using making high frequency field effect transistors and light emitting diode. Then it is also used in making heat sink. This is an example of heat sink. If you have opened an electronics or a computer before, you see something like this mounted on the processor. So this is to absorb heat that is generated in the electronic machine and the heat can spoil the electronic that's the electronic component. So heat sink will help to absorb the heat. So we also have what we call artificial diamond, which is actually made by heating graphite at a very high temperature and pressure for between 20 to 30 hours. And it is usually done using nickel catalyst or rhodium catalyst. So they are being used for various industrial purposes. We can now consider graphite. We can see the difference between graphite. You see graphite here, how dark it is. It is also opaque, very opaque. Consider it with the diamond you see here. You can see the clear difference between the diamond and graphite, despite the fact that both of them are carbon. They exist the same physical state but different. They exist in different form. So graphite can occur naturally as plumbago. The natural, so when it is called plumbago really, and then you see it in Austria, China, Western Germany, Republic of Korea, Madagascar, Mexico, Siberia, and Sri Lanka. So you can find graphite there. Although it is not uncommon to see graphite in Nigeria or and other parts of Africa too, but in a very, very small or insignificant quantity. So graphite is believed to have been formed as a result of volcanic heat on coal deposits over a long period of time. And the graphite atoms actually form a kind of parallel layers, which it is a form of crystal lattice and in hexagonal shape. So let us take a look at the property of graphite. We said diamond is the hardest substance known on earth, but graphite is one of the softest substance. Well, we cannot say the softest substance anyway. Let me say because it's the softest, let us consider it as a soft solid substance. So graphite is one of the soft substance we know. Graphite is very soft. It flakes easily. When you say it flakes easily, it breaks easily because of its layer. You know, we said the layers are parallel hexagonal, so the layers can easily slip over one another. So it is chemically, that is, graphite is chemically inert, but can be oxidized and converted to carbon 2 oxide, which is carbon monoxide in limited supply of oxygen, or carbon 4 oxide when the oxygen is in excess. So it is hexagonal pyramidal shape. It is a conductor of electricity. Diamond cannot conduct electricity because it does not have a free electrons in its outermost shell. But the valence electron, one of the valence electron of graphite is mobile. It is free, and that is why graphite can conduct electricity, but diamond cannot. So it also has a high melting point, but definitely not as high as that of diamond. Now let us take a look at the uses of graphite. We can see this. This is a grease, graphite grease, and it is always used as a lubricant to reduce friction in machines, in car engines, industrial machines, and so on and so forth. So this graphite lubricant, which is made of graphite and grease, are always used. Remember that we said that the layers of graphite can slip over one another because they are parallel to one another, and it's not that hard. So because of that, that application is used here in reducing the friction in engine. So it is used as lubricant. It is also used as electrode. Anything that will be used as electrode should be able to conduct electricity. And because graphite has a mobile electron in its outermost shell, so it can conduct electricity. So it is used for making electrode. For example, If you have broken a dry cell battery, the one you always use in your torchlight, for example, you will see a carbon rod inside it, a dark rod like this. So that is a graphite rod, and it is used because it can conduct electricity. Then you see it in a lot of industrial processes, especially in manufacturing of some compound such as sodium hydroxide and so on and so forth. So carbon or the graphite electrode can be actually used in the process as electrode to allow conduction of electricity. Another use of graphite is in making lead pencil. You can see this pencil here. This is an HB pencil. This tip is graphite. But you can make a different degree of pencils by adding different degree of clay. Pencil is actually made from graphite and a bit of clay. So if the quality of pencil you want depends on the percentage of graphite, but usually graphite is the major component in making a lead pencil. Then it is used in production of artificial diamond, just as we see here, these are artificial diamond. So graphite can be used to produce artificial diamond by heating it at very high temperature and pressure. Let us quickly look at the industrial preparation of graphite. So the process involved in production of graphite in the industry is called Atchison process, and this is done by heating coke for about 20 to 30 hours in the presence of air. So the air will be prevented in the attempt to heat coke. The air will be prevented from getting in contact, and it is usually done by using sand to cover the coke, and it will now be heated under that coverage. Now let us consider the differences between diamond and graphite. Recall that diamond and graphite are allotropes. In fact, diamond and graphite can be considered just like a sibling, and they are just like siblings. They have the same physical state, but they exist in different form. Like diamond is colorless and transparent. That means you can see through. Whereas graphite is a black opaque liquid. That means, I'm sorry, solid. Is a black opaque solid. That means you cannot see through. And so though somehow it shines, but you cannot see through, unlike diamond, which is transparent and has very high refractive index. Diamond is an octahedral crystal, whereas graphite is hexagonal in structure. Remember that we said graphite is hexagonal, and that you can slip, the layers of graphite can slip over one another. Then we have the density of diamond being about 3.5 gram per centimeter cube, whereas the density of graphite is about 2.3 gram per centimeter cube. Diamond is the hardest substance. It is the hardest natural substance that we know. Whereas graphite is one of the softest minerals. You can see the differences, we have prominent differences between diamond and graphite. Then diamond cannot conduct electricity because it does not have mobile electron in its outermost shell. Whereas in graphite, it has a free valence electron which is mobile, and that is responsible for the conduction of electricity. Then it is very inert. That is, diamond is very inert. It means that it doesn't react with some substance. Acid cannot even react with it. Acid cannot attack it, much less talk of water. Graphite is also somehow inert, but not very inert, because graphite can still react. For example, if graphite is heated in air, in limited supply of air, so carbon 2 oxide, popularly known as carbon monoxide, will be formed. Whereas if it is in excess supply of air, if it is heated in excess supply of air, graphite will form carbon 4 oxide, which is popularly known as carbon dioxide. So thank you for learning with us at Scholars Universal School. We expect you to fly high in your study. Kindly subscribe to our YouTube channel. Till we meet again, it is all good.